Hello friends, welcome back, and in this lecture we are going to discuss about the example of the Liskov substitution principle. You already know that we have discussed all these things theoretically in previous videos in the same playlist, and now we are discussing the code examples, the code samples to understand it better. So in that series, in that sequence, I'm just going to discuss about the Liskov substitution principle code example. So before we enter into the piece of code that I have written, and to explain that, before that, let us understand again what is the Liskov substitution principle, what it says. It says that the derived or child classes must be substitutable with their parent classes. So every child object, every derived class object should be able to replace the parent class object in entire program, right? So that is the main theme of the Liskov substitution principle. And in the, in more specific words, you can say, like, if S is a subtype of T, if it's a subtype of T, then object of T may be replaced with the objects of S. So here you can understand this, that if S is a type of T, which means that S is a derived class and T is the base class, then in that case, the objects of T, wherever you have used the objects of T, they should be able to replaceable with the objects of S without the change in the desirable properties of the program, which means that you should not need to change anything in your program if you are doing so. If you are going to replace the parent class objects with all the derived class objects, then in that case, you should not be forced to do any of the changes in your program or in your existing classes or in your modules. So that is the basic theme of this Liskov substitution principle. And also, last but not the least, to say that subtypes should retain the behavior of their parent type. All the behavior of their parent should be inherited completely by the subtypes. That is always done when you are inheriting something from the parent class, right? And children should be like their parents in all aspects. Same thing, right? So whatever has been written on the top. Now let me show you one example using which you can understand easily, like, what is the Liskov substitution principle. So I have created a class rectangle. In this rectangle class, I have two attributes, the length and the breadth. And I have written a constructor. In that constructor, I take two arguments. One is length, one is breadth. And then I initialize this L and B of the class attributes with these two arguments, underscore L and underscore B, which you already know, like how it is done, why the constructor is created. Now the second function is the calculate area, which is a public function, and this will be returning you the calculated area, like length into breadth. That is the area of the rectangle. So that will be returned by the by this function, calculate area. Now I am creating a square, a class. A class is square. I'm creating a class named square, and this class I'm going to inherit from the rectangle. Why I can inherit from the rectangle? Because square is a type of rectangle. Okay, and wherever there is a type of relationship or is a kind of relationship, then in that case we do the inheritance, right? So here we have a square class, and squares are always a kind of rectangle, so that is why I have inherited here from the rectangle. And inside the rectangle, inside the square class, I have only written one constructor, which is the square. And inside this constructor, from this constructor, I'm calling the constructor of the base class, which is the rectangle class. And the rectangle class takes two arguments, the length and the breadth. But since in the case of the square, length and breadth both are same, so that is why I have passed S two times, right? So this will come here, and then since this square has been publicly inherited from the rectangle, so I can always call this calculate area, this method, from outside this class. So that is what the example has been written here. So first of all, I am going to show you how I am using the rectangle class to calculate the area of a square. Suppose I use the rectangle class, the this base level class, and I give the length and breadth to calculate the area of the rectangle, right? So I can write like cout endl, and then I'm going to write like r dot calculate area. So if I do this, then I will be able to get the output as 15, because 15 will be the area 15 units square will be the area when you have sides as 3 and 5 for a rectangle. Now, if I want to calculate the area of square, right? So I will do 5 and 5 using the rectangle. If I want to calculate the area, then I have to give both of the arguments, the length and breadth as the same, because square is a kind of rectangle where the length and breadth are the same. So if I'm using the rectangle class object to calculate the area of a calculate the area of a square, then in that case length and breadth both I'm passing here. And if I run this, I will be able to get the output 25, right? So here I have got the answer, like 25 will be the area of the square. Now, if rather than using the rectangle, I can use square, right? So using the square, I am passing this argument as 5 here. Only one side is needed in the square, and then if I'm using this square s, then I'm just calling this calculate area, right? So I'm calling this calculate area, and this square will be calling this rectangle class constructor, which will set the length and breadth as same here, because from the square class this rectangle class constructor has already been called, right? So this is the way we can give the length and breadth, or you can say this side of the square as the length and breadth for the rectangle, which will become a square. So ultimately this rectangle class method calculate area is calculating the real area for the square as well, right? And here if I do this, I will get the same result, right? So here I can see like it's 25. So I can see that there is when I'm replacing the object, replacing the object of the base class from the derived class, then I don't have to do any changes in each of these classes which were already written, right? So this is this particular class, these two classes, where one is the base class, the other is the derived class. These two classes are following the Liskov substitution principle, and this is the example of the perfect classes which are maintainable, which will be easy to maintain later on when some new requirement comes, and the code will be more easier to maintain. So this is how the Liskov substitution principle helps you to write a maintainable code, right? If any of the class is not following this principle, then in that case what you will need whenever you will change whenever you will replace your base class objects with the derived class objects, then in that case you will need some changes to be done in these in any of these two classes. So if that is happening, if you are forced to do so, then in that case your classes have not been written in such a way, your base and derived classes have not been structured in such a way that they follow the Liskov substitution principle, and you need to correct that. So this is how you need to maintain the consistency in your class structure to get the desired results as per the Liskov substitution principle, get the desired code basically. Because if you don't write the code in this manner, then you will be you will be in other type of troubles later on when the new requirements will come and the question of maintainability will come. So with this, I hope you could have understood all these things whatever I have explained. So you can practice it yourself, you can understand it better, you can think of other examples, you can find out certain scenarios where this Liskov substitution principle is failing, and then you can try to correct that. Then you can try to find out how I can correct that. So that way you will be able to understand this Liskov substitution principle easily. Okay, so with this I would like to conclude this this lecture, and next video I will meet you soon again. Until then, have a nice day and bye bye. And before I close, I would like to say thanks to all of you, and also please subscribe my channel, and if you like this video, please give a thumbs up, and if you have any comments, any feedbacks for me, you can leave it in the comment section. Thank you. Have a nice day.